So this video is on factoring four-term expressions. Remember, when you're factoring, you're just trying to figure out like two expressions that multiply together to give you the original expression. Just like with 6, its factors are 2 and 3 because 2 times 3 gives me 6. When you factor, the first thing you always want to do is look for a GCF. If you can factor that out first, you should go ahead and do that. It's just easier to do that at the beginning. After that, you look for how many terms the expression has. If it has 2 terms, you'll factor it one way. If it has 3 terms, you'll factor it another way. And today we're going to look at 4 terms, which I call this grouping method. And so if you're making a little graphic organizer, we're going to be working on the 4 terms column here today. Here's kind of the steps, if you like to write down the steps for how to do this. So when you factor something with 4 terms, this may not make a ton of sense yet, but you group the first 2 and the last 2 terms together. That's why it's called grouping method. You're going to factor out a GCF from both groups, and then after that, whatever's left over should match. That's one of your factors, and then you combine the GCFs to make the other factor. Again, that may not make a whole lot of sense right now, but let's try an example. Feel free to pause the video and write that down. So, notice that this is an expression with 1, 2, 3, 4 terms. I'm going to go ahead and check, is there a GCF? Could I divide each of these by the same thing? And I can't. So, now I'm going to do grouping method. Grouping method says group the first 2 terms together and the last 2 terms together. Include that negative with the 4. This is technically like adding -4, so. Okay, what you're going to do now is in this first group, factor out a GCF. I can divide both of them by 9, and I could divide both of them by x squared. That would leave, I took out the 9, I took out 2 x's, that leaves 1x. 36 divided by 9 is 4, and I had x squared, I took out x squared, so that's all that's left. So just factored 9x squared out from both of those. Now in the second group, I'm also going to factor out a GCF. It's probably going to be a different GCF than this one. Notice I can divide both of these by -4. When I do that, that leaves x, and if you divide this by -4, it's +4. Okay, so you may notice that this and this are actually the same, and that's good, that's what I wanted, and that is one of my factors. The other factor comes from combining 9x squared minus 4. So put that here, 9x squared minus 4, and these are my 2 factors. So a couple things. First of all, it's a little confusing of like, why did I have it twice but I only wrote it once? The reason is, almost imagine all of this is one big term, and imagine all of this is one big chunk. And basically what I did was I treated x plus 4 like a GCF and factored it out to the front, leaving just 9x squared minus 4. So that's kind of what happened there. Also, I could always check my work by multiplying it out and making sure I got back to here. So like x times 9x squared is 9x cubed. X times -4 is -4x. 4 times 9x squared is 36x squared, and 4 times -4 is -16. It's a little out of order, but I did get back to the original, which is good. That tells me these are the factors of this. They multiply together to give me this. Also, this one actually keeps factoring. It keeps breaking down, but that's 2 terms and we're not there yet, so I'm just going to pause for now. And one final thing is, when you get to this point, the groups have to match. Like, let's say I just factored out a +4 instead of a -4. I would have been left with -x and -4, which wouldn't have matched this. So that's okay, just adjust it so that it will match. I'll show you an example a little later. Let's try another one. Again, it's 4 terms, so I'll do grouping method. But be careful, this one has a GCF. I want to factor that out first. So, see how they all divide by 2? So I'll bring that 2 out to the front, leaving 12x cubed minus 3x squared plus 4x plus 1. I just divided them all by 2 and put it here. That 2 we're pretty much just going to ignore until the very end. It doesn't get included in either of the groups. Don't forget to put it in the front at the end, but we're pretty much just going to ignore it for now. Okay, so now I'm going to group the first 2 terms and group the last 2 terms, and then factor out a GCF from both groups. The GCF here would be 3x squared, leaving 4x minus 1. Oh, sorry, this should be a minus. I could tell I messed up because the groups weren't going to match. Okay, so what's the GCF of this group? 4x minus 1. Can I divide either of them by the same thing? I can pretty much only do a 1. And so I do want to do something. I have to do something. So if 1 is the only thing I've got, then I'm going to put plus 1 right there, leaving just 4x minus 1. Again, because there wasn't really a GCF, except for just a 1. All right, so note that these 2 groups match. That's good. We've factored them out to the front, and that becomes one of our factors, 4x minus 1. The other factor comes from combining 3x squared plus 1. And we needed something here. This is why. We needed 3x squared plus something. In this case, just a 1. So these are my 2 factors. If I multiplied them together, they would get me back to the original. Be careful, I almost forgot it. There was a 2 that we factored out from the very beginning, so that 2 needs to still be in the very front, in front of the parentheses. Again, you could multiply it out and check your work if you wanted to. Make sure you get back to the original. You could do that in any order. So you could multiply these together, then multiply it by 2, or you could multiply these together and then multiply it by this last one, because commutative property. Also, the order in which you put these doesn't matter. So if you wanted to change, like put this one first, that's fine. Also, if you hadn't factored out a GCF from the very beginning, you would have got something like this as your 2 factors. Note that I have these 2 factors, but this one has a GCF in it. So I would just need to, at this point, factor out the GCF and get this. So it's okay if you don't factor out the GCF till the end, but it's usually bigger numbers, which is annoying. All right, one more example. There's no GCF here. It is 4 terms though, so we'll do grouping method. I'm adding a negative. Okay, in this first group, 2 and 3 are not divisible by the same thing, but I can factor out x squared, leaving 2x for this first one, and minus 3, because I took out the x squared. On this one, it's just like the last one where like I can't divide them by the same thing, so maybe I should just leave it as negative 2x plus 3 and just factor out a 1. However, if I do that, this is not going to match this. So what could I factor out of this that would make this the same as this? Note that the signs are just flipped. So in order to do that, just do a negative 1. Because if I divide both of these by negative 1, now this is positive 2x, and this is now negative 3, and now it matches. So that's a little tricky there. That repeats now, which is good. That's one of my factors, 2x minus 3. The other comes from combining x squared and minus 1. That went there, this went here, and there we go. This is another one where this actually is the difference of squares. It keeps factoring, but we're not to the 2-term stuff yet, so I'm just going to leave it for now. And again, if you wanted to multiply it out, make sure it works. 2x times x squared is 2x cubed. 2x times negative 1 is negative 2x. This times this, negative 3x squared. Negative 3 times negative 1 is positive 3. And again, it's a little out of order, but it does match the original.